Hello, my name is Gina Lonati, and I am a PhD candidate at the University of New Brunswick. On behalf of my co-authors, thanks for tuning in. Over the past decade, sightings of North Atlantic right whales in the summer months have increased in the southwestern Gulf of St. Lawrence, Canada, following an ocean regime shift in the Northwest Atlantic. The Gulf of St. Lawrence has some unique oceanographic and ecological features compared to traditional right whale foraging habitats. For example, 3 different species of Calanus copepods are present, including C. finmarchicus, C. hyperboreus, and C. glacialis, which have different life histories. We still have much to learn about the distribution of right whale prey in the Gulf, especially in areas where whales are feeding. We are addressing 3 main research questions with this study. First, where in the water column are layers of right whale prey, and are there differences between day and night? Second, what is the taxonomic composition of these layers, and how does that vary by day and night as well as depth? And third, how could these patterns influence the foraging behavior of North Atlantic right whales? During 3 summers, we conducted oceanographic sampling specifically within groups of 3 or more right whales in the southwestern Gulf of St. Lawrence at 16 different stations. During the day, we conducted photo ID and distance sampling of whales near our vessel. Then we deployed plankton nets and a variety of sensors listed here. The oceanographic sampling was repeated at night. We collected additional plankton net samples at night to assess through genetics which copepods are likely to vertically migrate in the water column versus which are likely to stay at depth in diapause. To answer our first question, we looked at data from the optical plankton counter, which counts Calanus-sized particles in the water column by depth using an optical sensor. In this figure, we have height above the sea floor on the y-axis and the number of Calanus-sized particles per meter cubed on the x-axis, with day on the left and night on the right. We observed layers of at least 1,000 particles per meter cubed within 10 meters of the seafloor during the day and night. However, it was difficult to consistently sample very close to the seafloor because we didn't want to damage our equipment. During the night, we also observed dense layers in shallower water. Another instrument, the acoustic zooplankton fish profiler, allows us to better investigate near-bottom aggregations of prey because it uses sonar to detect layers of plankton below the sensor without having to approach too close to the bottom. Again, height above the sea floor is on the y-axis, and the proportion of the AZFP echo at 455 kilohertz is on the x-axis. The AZFP detected maximum echoes within 5 meters of the seafloor during the day and night. The majority of the signal was below 10 meters during the day, while the signal was split between shallow and deep water at night, supporting our OPC results. To answer our second question, we examined the proportions of Calanus species collected in depth stratified nets. Only nets that captured at least 500 stage 5 finmarchicus, stage 5 glacialis, or stage 4 hyperboreus were included. Because we can't sample closer than 10 meters above the bottom with our nets, it was difficult to capture copepods in the deepest layers, so these sample sizes are small. During the day, the deepest net contained a mixed assemblage of the 3 species. During the night, the deepest net was dominated by hyperboreus, while the shallowest nets were primarily finmarchicus and glacialis. The net data combined with the OPC and AZFP results support the diel and ontogenetic migration of copepods. More specifically, hyperboreus, the largest and the first to enter diapause, remains at depth, while finmarchicus and glacialis are still vertically migrating. This is even further supported by our study of RNA to DNA ratios in copepods. Hyperboreus collected from deep nets had low ratios, indicative of diapause, while finmarchicus collected from shallow nets had higher ratios, suggesting they are more likely to exhibit diel vertical migration. However, not all finmarchicus may migrate, as there were individuals captured in deep nets that had ratios similar to hyperboreus and may also be in diapause. So how could these observed patterns influence the foraging behavior of North Atlantic right whales? First, the time of day and depth at which whales feed will dictate what copepods are on the menu. These results provide context for interpreting dive behavior data collected from tagged whales, and I suggest that you check out Jay Kirkham's poster with this in mind. Finally, foraging close to the seafloor may increase a whale's risk of entanglement in ground lines if those lines are elevated several meters above bottom. I'd like to thank my colleagues, lab mates, and sources of permits and funding, and I look forward to discussing these results with you further at the consortium. Thank you.